Hi everyone, my name is Zihan and I'm gonna do the question 1 of homework 6, so let's begin. So first it tells to find A that so that above defined is a valid joint density function, so apparently we should let this the integral of this joint density function equals to 1, and we can just simply calculate. We can put the integral of x inside and put the integral of y outside, and we substitute the fxy into it, and the interval is both from -1 to 1, and inside is equals to 2 over a, and this integral of y equals to 4 over a, so that equals to 1, so that we can have a equals to 4. And for the second problem, it tells to find if x and y are uncorrelated or not. We need to calculate the expectation of x, y, and the expectation of x times y. So first we calculate the expectation of x, y. Based on definition, equals to the integral of this area, the xy times fxy xy dx dy, and similarly we just need to calculate it. We put x inside and we put the integral of y outside, so the inside the integral of x equals to 2 over 3 y squared, and the integral of y is 4 over 9, and times the 1 for outside is equals to 1 over 9. Then we need to calculate the expectation of x. First we calculate the marginal density function of x, so the fx equals to the integral from -1 to y, this fxy dy, and this equals to 1 over 2, it's 1/2. Then we calculate the ex equals to, based on definition, equals to the integral from -1 to 1 x times fxx dx, and inside is 1 over 2x, so this is equals to 0 if you just simply calculate it, or you can say the 1 over 2 times x is actually an odd function, so the expectation is 0. Anyways, 0. So the exy actually is not equal to exey because ex is equals to 0. Actually, ey is also equals to 0, but we don't need to calculate it anymore because exy is not 0. So we know that x and y are not uncorrelated. And for the third subproblem, they ask us to find if x, y are independent or not. So because x and y are not uncorrelated, so definitely they are not independent. And for the fourth problem, it tells to find the joint density function of x squared and y squared. So here we just suppose the z equals to x squared and the random variable w equals to y squared. So we just need to find the joint density function of z and w. So the g equals to the partial derivative of z with respect to x, the partial derivative of z respect to y, and the partial derivative of w respect to x, and the partial derivative of w respect to y. And we just calculated it equals to 4xy. And for this z and w, we know there are actually 4 sets of roots, because x squared can equals to z. That means x can be square root of z or minus square root of z, and w can be square root of y can be square root of w or minus square root of w. So either it's 2 times 2 equals to 4. It's actually 4 sets of roots. So the first root is square root of z and square root of w, and second is square root of z minus square root of w, third is minus square root of z square root of w, and the fourth is minus square z minus square w. And actually the absolute value of this g is actually equal because we have the absolute value. It's 4 times square root of c times square root of w, and it's so this whole based on this theorem, based on this fundamental theorem we calculated is equals to 1 over 4 times square root of c times square root of w and times 1 over 4, and we substitute the density function of xy into it. So the inside is 1 plus square root of c square root of w plus 1 minus square root of c square root of w plus 1 minus square root of c times square root of w plus 1 plus the square root of c times square root of w. So the final result is equals to 1 over 4 times square root of c times square root of w, and we know it's actually when c and w is larger than 0 and smaller than 1. Of course, it will equal to 0 otherwise. So that's the joint density function of zw, also the joint density function of x squared and y squared. So for the fifth problem, it tells to prove or disprove that x squared and y squared are independent or not. So it's just z and w are independent or not. So here we calculate the marginal density function of fc and fw. So fcz actually equals to the integral from 0 to 1 fcw, that's cw dw, and we substitute the joint density function into it, and we finally equals to 1 over 2 times square root of z, and we now have similarly we have the density function of w equals to 1 over 2 times square root of w, and so we have that the joint density function actually equals to the marginal density function of z times marginal function of w. So we know that z and w are independent, which means x squared and y squared are independent. So that's all for the question 1. Thank you.